Welcome to the statistics section. Before covering this section, you should have looked at the function section, but besides that, no major references are made to any other sections except one small reference to the differential calculus section. But an outcome produced using differential calculus is just presented, but none of the specific concepts related to differential calculus are really covered in any depth. So you should be fine having just covered the functions section. That being said, here's the topics to be covered. First, I'll do a bit of revision, mainly related to the key fundamental concepts that you should be familiar with before going into any new material for the topic. So I'll mainly just revise key concepts, but won't really go through any major techniques such as histograms, ogives, or frequency polygons. Those are more the realm of grade 11 content, and you should already be familiar with it. But going into the exam, you should be familiar with these techniques because you definitely will be asked questions related to them. Next, we'll look at some new material, curve fitting, which will be related to determining functions to model a given set of data points. It will consist of various subsections such as interpolation and extrapolation and least squares linear regression, as well as covering how to use calculators to analyze statistical data and to determine various outcomes. And lastly, we'll look at the correlation coefficient, which is a way of determining how well the functions that we've determined in the previous section actually model and fit to our data. Let's begin. The first key concept to revise is measures of central tendency, which are basically summary statistics that represent the central point or typical value of a data set. The first and most basic measure of central tendency is the mean, which basically just represents the average value of a bunch of data. It's calculated by the following formula, which is read as x bar is equal to sigma x over n, where sigma x represents the sum of all the data points, with each data point being represented by x, and n just means the number of data points. For an example, determine the mean of the following set of data. So you have these values: 3, 4, 9, 11, 5, 12, another 5, and 7. So we first determine the sum of the data, which we get as 56, and the number of data points is 8 in this case, so n is equal to 8. Then the mean is just sigma x divided by n, which comes to a value of 7. Another important measure of central tendency is the median, and the median is basically the value at the center of an ordered data set. The data set could be ordered in ascending or descending order, but it's most frequently put in ascending order. And the median is basically the midpoint of the data set. Here's an example. Find the median of the following set of data points, which are 1, 10, 7, 3, 11, 2, 22, and 0. So the median is the value at the center of the ordered data set. Clearly the data is not in any particular order, so the first thing to do is to put it in some order. I'll put it in ascending order. And it's important to note that by value at the center of the data set, it doesn't mean the value between 0 and 22. So it doesn't mean like 11 or something. It means if you're to look at how many numbers are in the data set, the value at the center of it will be that which has an equal number of points above and below it. So in this set, there's 8 points. So n is equal to 8. Then you first determine what number point is at the center of the data set. And to calculate that, there's a special formula, which is basically n subscript median. Just think of it as median for now. I'll actually change it a little further on. But anyway, n median is equal to half times open brackets n minus 1 close brackets plus 1. So you just sub in the 8 and you get the value of n median as 4.5. So clearly we can't have 4.5 of a point. We can only have a 4th point and a 5th point. So whenever you have a number with a decimal point, it basically means you take the average of the two whole numbers between which this overall value would fall. So 4.5 would fall between 4 and 5. So the point at the center would fall between the 4th and the 5th term. Now we can calculate the value of the actual median, which would just be the average of the 4th and the 5th point. So the average of x4 and x5. x4 is 3 and x5 is 7. So the average of that is 5, meaning the median is equal to 5. The next important idea we looked at, aside from measures of central tendency, was measures of dispersion. And what these do is they show how scattered or spread out a set of data is. As an example, you could have this set of data with just the points 1, 2, 3, 5, and 7, and all of these points are relatively close to each other, and the minimum and maximum points are not that far from each other. So you can consider this as a less dispersed set of data. Then another possible set of data could be this data set, where we have the points -50, -3, 5, 67, and 512, where each of the points are quite far from each other, and the minimum and maximum points are really far from each other, with the difference between them being more than 500. So you can consider this set as being more dispersed. So the first measure of dispersion to know about is known as the range. And all this is the maximum value minus the minimum value. So we can apply this to these same two sets, where for the first one, it would be the maximum value of 7 minus the minimum value of 1. So the range would be a value of 6. Then for the other set, the range would be 512 minus -50, giving a value of 562. Then another measure of dispersion we've covered is the interquartile range, which is the difference between the first and third quartile, where the first quartile represents the data point 25% of the way through the dataset and is represented using Q1. And the third quartile is the point 75% of the way through the dataset. Let's determine the interquartile range for the dataset we looked at in example 2. So in a similar way as we did for the median, the first step is to determine the location of the first quartile along the dataset, which can be determined by the following equation, which is read as n of q1 is equal to 1/4 times brackets open n minus 1 brackets closed plus 1. And this set has 8 points, so n would be 8, and when you sub it in and do the calculation, you get position of the first quartile as 2,75. And since you can't have a 2 and 3/4 of a point, you see which 2 points the value lies between, which in this case would be the second and the third terms. Therefore, the first quartile is the average of the second and third terms, meaning the average of 1 and 2, which is 1.5. So that's the value of the first quartile. And it's a similar procedure for the third quartile, with the starting point being the equation for nq3, whose equation is very similar to the one for the first quartile, except now you have a 3/4 in front of the n minus 1 brackets. And when you sub in n as 8, you get the position of the third quartile as 6,25. Therefore, the third quartile lies between the 6th and the 7th terms. Therefore, it would be the average of the 6th and 7th term values, these being 10 and 11. Therefore, the third quartile is 10,5. Then now you just calculate the interquartile range, which is third quartile minus first quartile. And this gives a value of 9. And just a note related to terminology, sometimes the first quartile is referred to as the lower quartile, and the third quartile is referred to as the upper quartile. But I prefer this first and third quartile terminology, so I'll stick with that throughout the section. So these various measures of dispersion generally give a little more information than the measures of central tendency. So with the range, you get a basic idea of how spread out or dispersed the data set is. And with the interquartile range, you get an idea of the range in which the central half of the data lies. Then just something to know related to the median is a logical extension of the terminology used for the first and third quartile, and that is that given that the median would lie between these two, the median can be thought of as the second quartile and represented using Q2. So you may remember earlier on, to determine the position of the median in the dataset, I'd use the terminology n median, but from here on I'll replace it with n of Q2, and its equation was half times n minus 1 plus 1. And if you do the whole calculation, you get the median as 5. Then the next measure of dispersion to know about is the standard deviation, which indicates how the values in the dataset are spread out around the mean. And the standard deviation is calculated by the formula, which is read as standard deviation, represented using the Greek symbol sigma, is equal to the square root of the sum of all the terms minus the mean squared, divided by number of terms. It will make complete sense through the following example. For this example, you need to determine the standard deviation of the values in this data set, this being the same data set from example 2 and the previous example. So the first step is to determine the value of the mean. And as earlier determined, we get the mean as a value of 7. Then here's a full working to determine the standard deviation. So there's the mean we just determined, and this is the equation to determine the standard deviation. So you break it up into parts. The first of these is determine the value of this numerator, which is represented by this term. So what this represents is the sum of the values you get for all the terms when you subtract the mean value and then square it. Written out in full, you have x1 minus the mean squared plus x2 minus mean squared plus x3 minus mean squared, and on and on and on up to the last term, which is x8, where it becomes x8 minus the mean squared. Then you just sub in the respective values, which were 0 for the first term plus 1 minus 7 squared plus 2 minus 7 squared, and on plus 22 minus 7 squared. And you get these values, all of which add up to 376. And that means we now have this numerator term. So you sub in 376 as a numerator, and you know n is 8. So you find out the square root of 376 divided by 8, which simplifies down to square root of 47, finally giving a value of 6,86. Therefore, the standard deviation is 6,86. And the next thing to know is how to determine the standard deviation using your calculator. So if you have a Casio, the procedure is first click on mode, then choose stat, then choose whichever number corresponds to the option VAR, which will most likely be the number 1. And when you do that, you get an input table looking like this. And what this is for is to type in all the values in the data set. So then for the first value, you type the first value's number, then you press equals, and then the value will show at the top over here. And the input will have moved down to the second position. Then you repeat for the second value and keep continuing till you input all the values in the data set. And when you've done that, you press AC, and that stores this table of values. Then you press Shift and press whichever number has stat/dist written above it. So it varies with different Casio calculators, but for my calculator it's the number 1. And then once you press the number, you get a list of options. Then you click whichever number corresponds to the option VAR, which in my case is the number 4. Then you get most likely 4 options. Then you choose the one which looks like a sigma symbol with an X subscript. In my case, the sigma X option is number 3. And option 1 is N, and option 2 is X bar. And option 3 is sigma X. Then you choose sigma X. Then you just press equals, and it will now show the value of the standard deviation. Then I won't go into the full details of how you calculate the standard deviation using a sharp calculator, but the information will be summarized in the course resources. Then the last measure of dispersion to know about is what is known as the variance. And the variance is basically similar to the standard deviation, and in some cases is also used as a measure of dispersion. And you should know how to calculate it, but in general the standard deviation is preferred. But it's quite simple to calculate. It's basically just the standard deviation squared. And this formula is actually the one given on the formula sheet you receive with your exam paper. And it looks like this, where sigma squared represents the variance. And so to determine the standard deviation, you just adapt it by taking the squared to the other side and square rooting everything, which would give the previous equation we used for the standard deviation, this one. So those are all the key measures of central tendency and measures of dispersion you need to know about. And the next thing to know is something known as the 5-number summary. And what this is it basically combines a measure of central tendency, this being the median, with various measures of dispersion, these being the range and the interquartile range. And so the technical format of the 5-number summary is just a list of the following 5 values. These being the minimum value of the dataset, the first quartile, the median, which is also known as the second quartile, and the third quartile, and lastly, the maximum value. So you have the measure of central tendency being the median, which is the third term. Then the measure of dispersion, the first being the range, is represented using the minimum and the maximum value, which you can use to calculate the range. And then the interquartile range is represented using the first and third quartile, which you can use to determine the interquartile range. So the 5-number summary for the same data set of 8 values we've looked at in a bunch of previous examples. The value first introduced in example 2. And in the subsequent examples, we determined all these different values. And these were a minimum of 0, the first quartile lying between the second and third terms, therefore being 1.5, then the median lying between 3 and 7, therefore being 5, and the third quartile lying between 10 and 11, therefore being 10.5, and then the maximum being 22. So that's the technical list format, and then it can also be represented visually using a box and whisker diagram, which for this bunch of values would look like, where, keep in mind, the first thing you should do is set up a nice even axis, which includes all the 5 relevant values. So you set up your axis with even divisions, then the first end is the minimum value, then the start of the box would be the first quartile, then this midway point is the median, and the end of the box is the third quartile, and lastly the end of the second whisker is the maximum value. Then the very last thing to revise is symmetric and skewed data. So there's 3 shapes of data distribution that you can have. The first is left skewed data, which is also known as a negative skew. The second is symmetric data, and the last is right skewed data, which is also referred to as a positive skew. And then these shapes can be easily understood using box and whisker diagrams. So first you have left skewed data, whose box and whisker diagram would look like this, where the key characteristic is the left half of the box will be bigger than the right half. And the technical way to think of this is that the median is closer to the third quartile. Then you have the diagram for symmetric data distribution, which is quite simple to understand just from the name itself, where the data is roughly symmetric about the median. Then the last diagram is for right positively skewed data, where visually the right side portion of the box will be bigger than the left side portion. And the technical way to think of this is that the median is closer to the first quartile. And that covers all the important topics that you need to revise prior to starting the new material. And I'll end the revision section with the final example tying it all together. So the question says, a grade 12 class of 20 students writes a physical sciences test that is out of 40 marks. And these are the marks that the 20 students achieved. Then the first part of the question asks us to determine the 5-number summary. So pause and try it out by yourself first, then I'll just post the answer. Here's the answer. The table is just the data given in the question, just represented in a nice table form. And the 5-number summary is, the minimum value is 5 marks, the first quartile is 17 marks, the median is 31.5 marks, the third quartile is 35.5 marks, and lastly, the maximum is 40 marks. Then, the second part of the question asks us to draw a box and whisker diagram summarizing this data. Pause and try it out, then I'll just paste the final diagram. Here's the diagram. Then finally, the question asks us to comment on the mark distribution of the class. Pause and try and make some comments. Here's the main observations I could make by looking at the diagram. The marks for the class were negatively or left skewed. And this implies that there were many high marks in the class. And that covers everything for revision. We can now look at some new material, the first topic of which is curve fitting.